Sport podcast series. It's hosted by myself, Katie Mitchell. I am a PhD researcher, a registered physiotherapist, and certified athletic therapist. And on this podcast, we're going to be discussing the latest research in concussion education, management, and rehabilitation to thrive on in sport and life. Today, I'm really excited to have our guest and luckily to call my friend as well, Dr. Johanna Hurtubise. She is a PhD clinician. She completed her master's certification in athletic therapy, graduate diploma in neuroscience, and PhD in kinesiology and health science from York University. Our area of expertise in sport-related concussion, more specifically the behavioral effects of concussion history, motor control, and neuroscience. She is now an instructor in athletic and exercise therapy at Concussion College. Really jealous of her moving out west, as she was previously an instructor at the University of Winnipeg in their Department of Athletic Therapy. So all around, she is a rock star. Today, we're going to be talking about her journey through her PhD and the research that she conducted there, and as well her kind of bridging that into her career as an academic instructor. Welcome, Jo. I'm so glad to have you.
Hello.
So I thought we would just start talking about kind of how you got into, your research and sort of developed your passion for neuroscience, as you have your Dr. Neuroscience handle now. And we'll sort of talk about how that journey occurred and how you've come to where you are today.
So I like to tell people I kind of just fell into this. It wasn't something I, in high school thought I would be here or planned this route in my life, but I don't think I could have picked a better route for myself. So I first kind of got introduced to neuroscience and this area of motor control in my master's degree at York. So I was just taking some grad courses and I ended up taking this neuroscience course and I fell in love with it. And I fell in love with the instructor as well. And she was, presented it in such an interesting way to me. And so at the same time, I was actually still taking my athletic therapy designation. So I was still applying and kind of working towards that goal and that goal set. And any kind of medical profession. And so as an athletic therapist, I'm on the sideline with a lot of the teams and I work a lot of football in my past, especially. And one of the most frustrating things for me was concussions, because I felt like I couldn't help my athletes, right? So if my athlete sprains their ankle, I can assess it. I can usually give a pretty good idea to the athlete on what their recovery is going to look like, when they're going to get back, and what they need to do along that path and how to get the best outcome for them. Concussions is just such a wild west out there that I felt like I couldn't help my athletes. I couldn't answer their questions. And that was really frustrating to me as an athletic therapist. So when I finished all my master's and my athletic therapy, I was kind of presented the opportunity to continue researching specifically concussions with motor control at York University and do my PhD. And so the opportunity was there and it kind of spoke to two different interests that I really had. And my supervisor for my PhD really loved that I was a clinician. She thought that I brought something different to the research table. And that was important to me as well. So that kind of drove me into starting the research aspect and starting my PhD.
Yeah, and this is where I think our paths really kind of parallel with each other of how we actually got into research, because I don't think either of us really saw us doing this at a younger age, but kind of our clinical interests and questions sort of drove us there. So why don't you talk a little bit about kind of the initial research you got involved with Lauren Sergio and just sort of like your initial projects and kind of what the results of those projects were.
So my initial project that I literally jumped into, I even started it before my PhD started, was I did this project. It was looking at motor control behavior. So looking at kind of like reaction time, movement time. And I got to be able to do this with the NHL draft prospects. So that was really interesting to be able to go to the NHL camps and test some of these really elite athletes on how they're performing. And we looked at those who were healthy and those who had previous history of concussion. So all these athletes are asymptomatic, they're cleared, they're ready to go, and they're ready to return to play. So from that, we kind of found that actually, we could still find, if we did really complex testing, we were able to find a few deficits with these elite athletes who had history of concussion. And that was a really new result that, we're saying, hey, even though they're clinically recovered, we can still find a few of these deficits. We had done this similar research in the lab previously with high school level or children, and we actually we found a lot more deficits with those. We weren't finding the same level of deficits with elite level athletes. So that kind of led us to kind of question, like, does skill level have a role to play in how we're seeing these deficits after a concussion, and how long do these deficits last? And that kind of led to a lot of questions on what's really going on in the brain, like what's going on from a motor control perspective, right? So behaviorally, we can look at all these things, but and we make kind of these knowledgeable assumptions about what's going on in the brain, but we don't actually see it, right? We're using kind of previous knowledge to figure that out. So that kind of led us to kind of my next kind of big area of focus that I spent most of my time on, was looking at neuroimaging. So actually looking at the brain of people who had previous concussion, and this is where I kind of dove into post-concussion syndrome. And so someone who has long-term effects of concussion, and seeing, like, are there actual structural differences in these individuals' brains compared to people who've never had a concussion that we can actually visually see that might help us to explain these behavioral differences we're seeing in the motor control system. And so that's kind of how my projects kind of went forward. And I think in research, you kind of see that when you're doing a research project, you typically end with like a bazillion more questions than when you started. And that's how research kind of works, is that you have all these new questions that you need to answer, and then you keep kind of going along, and you bridge in all these different areas of trying to figure out the answers to the questions you've created for yourself.
Yeah, for sure. I know exactly how that works. It was interesting because even when we initially met, I remember having this big conversation about how we wanted to create more robust testing to be able to match the demands and kind of the experience level of more elite level trained athletes. And it's kind of continued on that pathway throughout even my own research, where I've seen differences in just like the performance on certain tasks when someone is more highly trained, and sort of different perceptual paradigms, for example, being able to use like those visual motor skills that are trained in sport along the line. So that last part you're talking about, where you kind of brought in the neuroimaging, I remember this study because we did the Cognitivemotor integration task. And if you could explain a little bit what that task looks like, and then you were linking it actually to the MRI imaging that you did to actually see if they correlated in performance, which was really interesting.
Yeah, so I can't take credit for designing this task. This was designed by my PhD supervisor before I got into the lab. So I just want to premise this, that this task had been really well developed before I stepped in. So it developed, and I mean, like, you can go back, I'm sure there was monkey studies, I don't really know, that wasn't really my area, right? So this had been really well developed in healthy individuals. So we know that this task worked. We know what areas of this brain this task was already targeting. So when I came in, I was able to use it clinically, which is, I think, really important for people to understand that these tasks take a really long time to develop, to understand really what's going on in the brain. So my supervisor had developed this task, and we named it BIRDIE, which stands for Brain Dysfunction Indicator, and it tests cognitive motor integration. So for people who don't know what that is, it's basically thinking and moving at the same time. So a lot of times in research, we do cognition and we do motor as two separate silos, right? So I know, Katie, you've talked about this before, right? So there's a lot of tests that look just at cognitive, and there's a lot of tests that look just at motor control, right? Balance, coordination. But there's really not anything that integrates these two. And life, really, we integrate these two. Sport, we definitely integrate these two. So why are we testing them in these silos? It's not really real world application. So this task was literally just a reaching, like slide your finger on a screen like you would on a tablet, like not really a complex task from a motor perspective, but still targeting those motor areas in the brain. So this task had a few different conditions. So one was just simply if a target showed up, you would just slide your finger to the target. So you're looking at it, you can see it come up, you just move your finger as fast as possible. That's simple reaction time, really, really simple task, purely motor. We don't really have to think about it very much. It's innate for us to do that. And then we had developed a really complex task. So we would be looking at a screen in front of us, but actually moving our hands on a different plane. So down here, and then when the cue showed up on the left-hand side, we'd actually have to move our finger to the right side, to the opposite direction in order to get to the right spot. So we're actually have to flip everything. So I always use examples, right? So if you are a PC computer user and also you try to go on a Mac and you have to slide the opposite way on those stupid mouse pads, and like the amount of cursing you do because you just can't figure that out, that's because that's really complex for us. We now have to start thinking, okay, I'm on a Mac, I need to like move up to move down, and we actually have to start thinking about what we're doing. And so when that happens, that's cognitive motor integration. So we had created this really simplistic task to target those areas of the brain in order to see what was going on. And so what we found is that when we do just simple tasks, we don't see these differences, we're not noticing anything. But when we start integrating this cognition, we start making them think about the movements they're doing, that's when we're starting to see these behavioral deficits come up.
Yeah, definitely. I remember doing that task. It was pretty complex. Like it sounds simple to do, and then you try it and you make all these errors. And so some of the findings that you guys, I was looking at the papers today, but the was partly like the accuracy of those movements. So there was like more variability in the accuracy that you guys found in that, and also just like reaction time a little bit too, like the actual time it took to get to the target.
Yeah, so it depends on the group that we were testing. What we kind of found, so I'm going to try to like, and so when you're looking at the hockey players, yeah, we found minor differences in reaction time, and a little bit in accuracy as well, but reaction time was the bigger one that we found things in. So, but again, I want to point out that in comparison to, let's say, the high school or varsity level athletes, they had a lot larger differences in reaction time and accuracy. And in the children, there was even, I think there was movement time. That was not my study, but movement time was also affected. So they had 3 areas in which they were impacted. And so we know that, like, hey, and the interesting thing for us is that varsity level athletes and these hockey players we're testing are actually the same age. So it's not an age development thing. It's definitely a skill development aspect. And so, again, I like to tell people, I don't play hockey at all. Like don't skate. I don't know how to do anything. If you put me on the ice and ask me to do, I don't know, a go around the pylons and shoot a puck, the amount of brain power that will take me to do that is significant. Like I will be struggling like you wouldn't believe. So if you give me a concussion, even months later, like you probably still be able to see these deficits really easily. But if you have an elite athlete, take any of those NHL players out there and ask them to do that, they can do that with their eyes closed, skate backwards. I don't care. No problems doing that. So if you give them a concussion and then do that test again, they're going to be like, I can do this if I'm half asleep. Like it doesn't matter that I don't have the brain power anymore to do this. So I think we really need to adjust kind of our expectations and how we're testing people and motor control from a clinical perspective. And that's really what my studies were kind of looking at.
Yeah, so looking at more of like a spectrum of training experience of like, if you're looking, and particularly with those adolescents and children, it's likely that the development of those neural areas wasn't quite up to where and some of them could be further ahead than others. So there's variance in just the development there. So there's usually a lot more that found, and I've found that similar with some of my work as well. And then it kind of levels out where everyone's sort of on the same playing field, and then you get into the varsity and professional age groups. But it's interesting. I love that example. Like I always talk about stick handling, of where like a novice stick handler is going to have to look at the puck the whole time, whereas an expert hockey player is going to be able to see the ice and see, like, you know, their teammates, their defender, kind of make decisions and have that like bigger attentional reserve to perform tasks, because they don't have to focus so much on like the rudimentary motor task of stick handling for them, because they've got so much experience for it. So 100% agree with that. I think it's that was really awesome work that you did. Now in the groups, we looked at the post-concussion syndrome with the imaging. Do you want to touch a little bit on kind of what you guys found with that, and kind of correlating it to that cognitive motor integration task?
Yeah, so this I don't know how much I can say about this. So this project was quite a lengthy project. So imaging is not something that you take on lightly. It's and so I actually chose to do females with post-concussion syndrome, and I chose this for a few reasons. One, in the literature, females have been shown to be more likely to have post-concussion syndrome. So we chose to focus on females simply because we thought we'd be able to get more participants, and they're affected more from a clinical perspective, who we see in the clinic more frequently. Don't know if that's true or not, and just that's what literature is saying. We did want to do both males and females in one study, simply because I only could have so many. And that's another confounding factor. So males and females' brains do differ. So I didn't want that as a confounding factor in my study. So I chose females, and we wanted to look at post-concussion syndrome. We actually chose that one because, we thought, hey, if we're going to see these neurological changes in the brain, we figured we'd probably see them most likely in post-concussion syndrome, because they don't have symptoms for a week. They have symptoms for quite a long time. So if there's going to be structural changes, it's probably going to be in this group. That was our theory when we went in and decided to start looking at this group. So interestingly, we did not find the same amount of behavioral changes between a healthy group and post-concussion syndrome. And so just speaking behaviorally, this was a really weird finding to me. I thought, hey, like, why are we not seeing these huge differences in a behavioral task? And we sat kind of, as a lab, we tend to discuss findings that are unusual and discuss why this might be. And it could just be because I had a small group. So statistically speaking, I didn't necessarily have the power to find these differences. And I don't really want to get into statistics today, but it could just be my numbers. But it could also just be that, my post-concussion syndrome group just had so much variability. Some performed well, some performed horribly, some actually performed really good. So it kind of really skewed my numbers. So it was really hard to know because they were so all over the place. So, and that's, I think, speaks to how post-concussion syndrome is. We put it in a box, but it's so complex that for me to know that these post-concussion syndrome individuals had motor deficits, I was, what is it, like shooting something in a barrel? Like I was just, like
fish.
Thank you. Shooting fish in a barrel, right? Oh, that's not the right one. I was, I'm trying to find
shooting blanks.
and I think, for me, it kind of didn't speak to that. My task was not accurate. It was more that post-concussion syndrome is so complex. So I think my research almost kind of led to like, hey, we need to figure, this is like so rudimentary starting, that my research is almost trying to help people understand that we need to find those people who have motor control deficits, because they might need very different therapeutic approaches than somebody who may not have this. So this might be a way to find people who have these motor control deficits. So we they didn't have these behavioral differences, but that doesn't mean that it wasn't important. So that was really hard to correlate it to any of the differences that we saw from a neurological perspective, because we didn't see these behavioral differences. So I don't know how much I can speak about the neurological stuff that we did find, because one paper is published, but one paper is currently being written up to be submitted. So I don't know how much I can say about that
That's
paper.
Fair.
But I will kind of point out that we did do two different kind of a few different types of neuroimaging. And I think I want to point out, so there's standard neuroimaging that you get done in the hospital, and we know from research that you do not see any concussions in standard neuroimaging. So what I'm doing is advanced neuroimaging. So this is not something you would get done at a hospital. This I did a DTI, so diffusion tensor imaging, which is looking at white matter tracts. And then I did a structural MRI, but how I analyze that data is different. So I actually took a structural MRI, so anything you normally see, and I'm actually looking at cortical thickness as well as volume of certain motor areas in the brain. So I'm looking at it in a lot more detail. So just what I'm looking at is different than a structural or a standard MRI. And so what I will say is that this is sometimes how research works. And one of the interesting things had to do with the cerebellum. And that's what the one paper is that I'm working on to get published. And Katie knows the cerebellum is one of my favorite areas of the brain, and we can talk about that. But how we found this is clear, like this is like classic research, like, oh, oops, you fell into this. We decided that we did our imaging. We actually decided, usually in standard imaging, we don't include the cerebellum in brain scans. It just doesn't fit. People cut it off. They don't find it as important. But we were like, no, we want to include the cerebellum. So we actually made sure that when we were doing images, we could get the cerebellum in our images. And so when we do imaging, I'm not the one doing the imaging. I just want to make that I have a technician who has no involvement in my research whatsoever, who sits there and puts somebody into the MRI and does all the imaging. And at a research institution, if we see anything that's even minutely different than normal, we send it off to a radiologist to get looked at. Usually the radiologist is like, no, it's nothing, but we have to do our due diligence because we are not a hospital. We're not, people. And the first few people that we put in that had post-concussion syndrome, our technician was like, hey, the cerebellum looks like a little smaller than normal, so that's weird. And she had no idea if this was she did not know if this was a control person or anything about them. And we literally sat there one day and we said, maybe we should look a little bit closer at the cerebellum then, because this is an interesting finding that we didn't even go into looking at. So yeah, that got us really excited about kind of our research and the cerebellum.
Yeah, and that's just funny and how it actually is one of your favorite areas. I basically I wrote a paper on the cerebellum a couple of years ago that talked about like plasticity of the cerebellum. Like, do you want to speak to just like some of the kind of the main functions that is related to concussion that is potentially affected by the cerebellum? Like, not necessarily related to what you found, but so outline some of the key features of the cerebellum that is important for people to understand, like why it is important.
Yeah, I think the cerebellum is just kind of an represented part of the brain when it comes to concussion research. So the cerebellum's functions, the cerebellum literally means little brain, and it's kind of mimics the cerebrum, or the main part of your brain, in both function and structure, right? So it has the two lobes, people mainly think of the cerebellum as being a completely motor structure. And while it does do a mostly motor, it's not all motor. So it does motor, which I'll get into in a second, but it also has cognitive functions and emotion functions, just like the cerebrum. So it has a really complex kind of, and it really is a little tiny brain. But the difference is that it's subconscious. So we don't actually know that our cerebellum is doing anything, but it's always working. So this is kind of all that unconscious things that you do, the cerebellum's playing that role. So cognitive, emotion, and motor. And so it's big motor components, right? So it's involved posture, balance. So it has vestibular components to it for the posture and balance. It does a lot of coordination, so anything, right? Juggling, doing all these things. Walking is really important, so gait. And it corrects movement. So I always use my coffee cups, right? If I was trying to reach out for my coffee cup and I wasn't reaching in a correct line for it, my cerebellum would subconsciously correct that. So correcting a lot of movements. I like to tell people, if you want to think about the cerebellum's functions from a motor control perspective, think about a night out at the bar, you're walking home, right? So cerebellum dysfunction and testing for cerebellar dysfunction is literally the same as all the drunk tests, right? The sobriety tests, walking in a straight line, doing this, that's your cerebellum dysfunctioning if you can't do that. So when you're drunk, your cerebellum is not working so well. So that is the main function of the cerebellum. Obviously, after a concussion, we test the cerebellum. You know, if you do the sport concussion assessment tool, Romberg testing, any of the balance testing, we do coordination testing. This is all cerebellar tests, every single one of them. You know, usually we don't see it quite so dramatically as someone who has cerebellar ataxia, but someone might have balance problems, right, or coordination problems. And it's really interesting to me that clinically we threw in cerebellar tests, but when you looked at the literature, no one's researching the cerebellum. No one's looking at it. And to me, that was kind of crazy. You know, we look at kind of behaviorally, we're testing it, functionally we're testing it, but we don't know why we're testing it. So that kind of spoke volumes to me, is kind of like, maybe we should look at this.
Yeah, it's such a deep, like, subcortical structure too, that anyone who's tried to kind of capture it is potentially, you know, it's so generalized. If you are simulating like kind of around that base of so the cerebellum is like located at the base, essentially at the base of the back of the brain. So you could be getting other structures if you're trying to get an image of it. So using something as, you know, accurate and sensitive as you were is not like easy to come by either. So there's not a lot of labs that would have access to that type of advanced imaging. But yeah, I always think it's so important to incorporate a lot of those functions. Like you're talking about, like the coordination, you break that down into like rhythm, accuracy, and like precision of movement, adding targets to things, different timing. So using like a metronome, that's the kind of thing where I think of that cerebellum kind of like tinkering around in the back of the brain to correct all the errors. It's like this error detector that fixes all the movements, but also even movements of the eyes, different things when it comes to vestibular function as well, that it plays a role in. So let's switch gears a little bit and talk about kind of your transition into more professional teaching and your career, and kind of how you're moving forward with taking the information that you've learned in your research and kind of building that into your future of sort of educating other students and clinicians, and kind of the approach you're taking for that.
Yeah, so I love teaching. It's fun. I don't know. So I'm teaching in the athletic therapy programs, which I love because now I get to teach clinicians as well, and I'm teaching the clinicians in an area that, you know, I'm a clinician in, so I love, and we got to move forward in that. You know, and as a student, I feel like I didn't get that motor control knowledge that I wish I did. So it's something that I'm hoping to bring forward to students, a little bit more information about motor control and just how our body moves, but as well as a little bit more information about concussion, right? So, you know, athletic therapists are on the sidelines, so we are some of the people who, you know, really deal with concussions, especially sport-related concussions, on a regular basis. And I think there's a lot of misinformation out there. There's a lot of, you know, there's so much information about concussions out there that it can be very difficult to really understand what's the best approach for your patient. And you know, athletic therapists do get taught this information, but it's rapidly changing. And I think, you know, especially when we talk about post-concussion syndrome, it's so complex that that's not really taught as well, or previously hasn't been taught as well, because it was so complex. And we're really good at the sideline assessment and the return to play for athletes. Like, that's what we learn. But what about the athletes that aren't getting better, right? Those are the ones you're going to see clinically. And I think those need to be a little bit better understood. So I definitely try to bring that forward about concussion, and not necessarily teaching them like, hey, this is the way you need to address concussions, but just kind of teaching them about the neuroanatomy so they understand that, the visual system and the oculomotor system are not the same system. So we can't assume like you're not doing visual assessment, you're doing an oculomotor assessment. And why is that important to know that that's different? So some just some of the basic neuroanatomy to understand the tests that they're doing, and as well as just how to research and how to critically appraise some of the research that comes out or the courses that come out, because the information is so continually ongoing. I'm never going to be able to keep up with that teaching them. If I teach them 1 year, 3 years down the road, that's going to be out of date. So I'd rather teach them how to find good resources and how to critically appraise what's out there so that they can educate their patients as well as keep up with kind of the best practice out there for concussion. And I'm actually really excited. I just got a motor control course given to me. Yay. So
Yay.
I will be specifically working on motor control, and I just started looking at it this morning before this chat. So we'll see what comes of that, but that's my wheelhouse, right? So I'm pretty excited about teaching that.
Yeah, that's great. I think it's so important to, and we've talked about this numerous times too, of like understanding the basic foundations of like neuroanatomy and neurophysiology to understand the dysfunction of it. Because I think that the dysfunction gets taught and then they know how to assess a dysfunction, but then they don't know how to adapt it when it doesn't quite, check the box. If someone presents a little bit differently, then, they were taught as a specific guideline of like, oh, if this is what you do, if this happens in this test. And it's like, well, what if something outside of even the research occurs and they don't know what really they've even been testing to fully understand how to rehab or intervene with it. And I think that's where I think that a lot of this like big wild west of sort of even research and education has been pumping through the last few years, but they've skipped ahead almost over all of that fundamental stuff. And that's where like me and you have kind of spent years learning that ourselves. And so I think now that we can translate it to other clinicians, it's like a game changer. A lot of people are like, wow, the dots are connecting. And, even they're seasoned therapists or students or new therapists, where, there is so much content in these programs already. It is hard to incorporate a lot of it in as general kind of standards of practice, but it is so important, like you said, to critically appraise what you see and understand that it's not just like a kind of black and white, that it is very gray and super complex. So yeah, that's so awesome that you're moving ahead with that. And yeah, it's very exciting that you're now out west and living the dream out in BC. So talk a little bit about what you're going to be doing next, and like any kind of additional things that you're planning to do in the future.
Yeah, well, I just moved here, so this is still new for me, but one thing you kind of talked about it is I am planning on doing some more educational content for clinicians. So right now I'm teaching the students, but the clinicians that are already out there need this information as well. And I think you made a really good point, is that, we're teaching dysfunction, we're not teaching the basics. And I do also appreciate the fact that I went to school for an additional 4 years and also took a specialization diploma in order to have the amount of neuroscience anatomy that I have. So I can appreciate that somebody doing an undergrad or, this athletic therapy where they have such a broad amount of information they need to learn, that they're not going to learn the level that I've learned. Like, I get that. So this is where continuing education comes in. Right now I can teach clinicians kind of to build upon the basic knowledge that they were provided, and to build it and to learn even more about neuroanatomy, because it is really complex. So you could do this. I'm still learning, right? So it's something we could continually to learn on. And I think you hit the nail on the head where like you really do need to understand it to understand how to treat it. And I think that's something that we lack. So I'm currently trying to develop just a course for clinicians that's really, really focused on science, and more focused on kind of, the neuroanatomy, the general function, understanding what we're already doing. I'm not trying to reinvent the wheel. I'm not trying to throw out new clinical tools or practices, but just kind of how do we, what does the SCAT-5 really assess what are we looking at? Why does this work? Why does this not work? And we look at it related to physiology and anatomy of the nervous system. So I'm trying to develop that. It's a bit of a slow process because, other job. And then I'm also a contributing faculty member to St. Augustine University in the US. So I teach athletic trainers in the States, physiotherapists in the States, and occupational therapists that are doing grad school. I teach them a concussion course. And I'm also working on still publishing some of my PhD work, as I just mentioned. So that's kind of on the docket right now. All my conferences I was supposed to attend obviously got canceled. So, now I have to figure out kind of what's next on that. And I'm still a little bit involved in research. So at York, still Dr. Lauren Sergio and Dr. Lorianne Hines. So Dr. Sergio was my supervisor, and Dr. Lorianne Hines is the director of the AT program. She was also involved in my research. They've kind of taken my research and they've continued forward with it. We're working on making a more clinical, clinician-friendly approach to that Cognitivemotor integration test. We're making it more full body, so an athlete who actually runs and moves and does a full motor task based on those same networks and same ideas of our computer task. So literally on the field with a stopwatch, like any clinician could, we want to make this really friendly. So that it's a little bit more, hey, can we use for testing and for rehab and return to play? And so that's being done. I'm not doing it, but I am involved as kind of somebody who helped get that started. And so I do help with that. And I'm hoping in the future, once things get a little bit back to normal in terms of sports and things happening, to start collaborating on some concussion research with some researchers that I know across the country, getting that concussion information and a bunch of different projects. So my current position allows for me to collaborate and kind of do whatever direction I want to go with that. So that's really exciting. Just obviously with COVID, that's a little hard to do right now. So.
Definitely. Yeah. No, that's all really exciting. You have a lot of balls in the air right now, but so much to look forward to as well. And I know that once kind of our research labs open up again to actually do in-person research, I'll be looking forward to seeing some of the stuff coming out of York that you're consulting on. And but yeah, that's so much information. Like whenever I have talks with Joe, we could go on for so long. And we end up kind of having these big brainstorming ideas. And we've collaborated on a few educational things as well at conferences and hopefully in the future too with some other offerings. So why don't you tell everyone where they can find you on social media? I know you have your Instagram account. You can do a little plug for that. And look out for your courses coming out and that kind of stuff on that. So
I started a new Instagram account. Called Dr. Neuroscientist. That name came because my old clinical manager used to call the conferences I went to the neuroscience conferences. So it's throw to her. So Dr. Neuroscientist. And, I just started that new account as a way to kind of connect with other researchers and clinicians and people who may be interested in this and in the brain. And I will hopefully be, when I do get my courses developed, be kind of giving that information through my Instagram account. And if you want to know more about my research, I do have a Google Scholar account and as well as a ResearchNet account and a LinkedIn account, which I'm really bad at updating. So that I can't say that one's the most up to date, but Google Scholar has all my research linked there. And if it's not free access and you want access, just send me a message on my Instagram and I can get you that. So that's not a problem. So.
Awesome. Well, thank you so much. It's such an exciting first episode to have you on. Thank you again. I really appreciate your sharing your knowledge and your insights. So check her out on Instagram at Dr. Neuroscientist. We'll add Joe's name and her Instagram account in the show notes as well for everybody to access there too. All right. Again, thank you so much for listening, and we'll chat again soon.
Thanks, Katie.
Concussion Talk Podcast is presented by HeadCheck Health. HeadCheck Health bridges the gaps in concussion care through simple, powerful technology. Join organizations like the Canadian Football League, Track Factory Racing, the Canadian Junior Hockey League, Eastern Washington University, and Volleyball Canada, who rely on HeadCheck Health to improve communication and optimize care. Visit headcheckhealth.com for more. Music at the beginning of this podcast is by Ben Sound. www.bensound.com.